Welcome back to geometry. We are at section 6.3, proving that a quadrilateral is a parallelogram. From before, we learned that opposite sides are parallel and congruent in a parallelogram. We also learned that opposite angles are congruent in a parallelogram. Diagonals will bisect each other in a parallelogram. And we also learned that consecutive angles are supplementary, which means they'll add up to 180 degrees. All right, with these proofs below, on a scale of 1 to 10, these proofs are about at a 50, meaning they're going to be 5 times as hard as any proof that you have ever done. So just know that going into it, that these are very challenging proofs. And really, if we look at this first proof, which is probably the most challenging proof out of the 4, we're told that we have a shape that's a 4-sided polygon because we have a quadrilateral with both pairs of opposite sides are each congruent. Well, when we make these markings, we already know that this shape is now a parallelogram. However, this is called theorem 6.1. So what we're being asked to do is to actually prove this theorem. But the trick on this is we can't use opposite sides are each congruent. We have to either use opposite sides are parallel, opposite angles are congruent, diagonals will bisect each other, or consecutive angles are supplementary. But anyway, so that's our challenge. And really, you would have no idea how to do this. Okay, so let's just learn together. Statement 1, again, this is always going to be the first statement. It's given. We can put G. Our second thing that we're going to do, first, let's label this A, B, C, D. And we're going to draw in one diagonal from A to C. And by doing that, you see that we've created 2 triangles. Okay, now let's explain what we just did. We're going to draw diagonal AC. And we're allowed to do that. We can put the given as well. Okay. From there, hopefully you see that this side is going to be reflexive and congruent to itself. So we can say that AC is congruent equal to CA, and that's by reflexive property. Next, in doing that, hopefully you can tell that we have now created 2 triangles that are both the same shapes. They're each congruent, so let's label that. We have triangle ABC is congruent and equal. And if I go ABC, I went 2 to 1, so 2 to 1 would be triangle CDA, and that's going to be side, side, side. Okay. From there, what we can say next, and we don't actually need to say this in our proof, it won't do anything for us, but I just want you to see that we could say that angle B is congruent and equal to angle D. Okay, and why am I allowed to say that? Let's think about it. Angle B is congruent and equal to angle D. Well, if you look at triangle ABC and triangle CDA, if you underline B and underline D, these are the same angle in those 2 triangles that are each congruent. Therefore, I can say that by CPCTC, these 2 angles are each congruent. Now, if we were to erase our first diagonal and then draw a new diagonal, we could do the same thing and then prove that opposite angles are each congruent. But that would be too easy, all right? And we want to make it challenging for us. So we're going to keep going. What can we do next? Well, here's what we can say next. All right, actually, I'm stumped myself. Let me look at this again. All right, I do see it. Sorry about that. It even takes me a little while sometimes to do this. Let's focus on, again, that these 2 triangles are each congruent. And I'm going to put angle 1 here and angle 2. Now, I see what you're thinking already. You're saying alternate interior angles. That's why angle 1 is congruent equal to angle 2. But that's not true. Okay? The reason why this isn't alternate in interior angles is we don't know if these two lines are parallel yet. We're not sure. We're not sure if these two lines are parallel. If we did, then we could say angle 1 is congruent equal to angle 2, but we don't know that. What I'm saying is that these two angles have to be the same by CPCTC. Okay, and how did I get that? Well, underline C with 2 marks, underline A with 2 marks. You see that these are the same angle in their respective triangles. So angle 1 is congruent equal to angle 2, and that's going to be again by CPCTC. All right, we're going to continue this proof because we're not done yet. We'll do a statement and a reason. And let's keep going. All right, statement 7. What can we say next? Well, since these two angles are each congruent, then what I now can say is that BA is parallel to CD. And let's just get that down and then I'll explain why. So BA is going to be parallel to DC. And the reason why those two lines are now parallel is by the converse of alternate interior angles. Oh, sorry. The converse of alternate interior angles. Okay, and the reason why we can say that these lines are parallel is that angle 1 and angle 2 are each congruent. Now, if you think back on all the problems that we have always been given that two lines are parallel. We have always been shown that. And so when we have one transversal, okay, and these are horrible straight lines, but you know, we can say angle 1 and angle 2 are congruent because they're alternate interior angles. Well, this time we're going to work backwards. We don't know that these lines are parallel, but we know that they're each congruent. You know, it's just like if, let's try and draw this better. If we had this, okay, and these lines look parallel, but we're not really sure. If we were told that the measure of angle 1 equals the measure of angle 2, then I can say that line L is parallel to line M. Okay, and same thing here. Okay, so it's the converse of alternate interior angles. All right, then for 8, since we've shown that these two sides are parallel, if I can show that BC is parallel to AD, I'm finished. Okay, so next we're going to say that angle 3 is congruent and equal to angle 4. All right, and so we can say angle 3 is congruent and equal to angle 4. Now we have to think about our reason, and it's not going to be alternate interior angles. Again, we don't know if these lines are parallel yet, BC and DA. But when you look at our triangles, here we have DAC and BAC, and so that would be angle A, and so let's put 3 marks for angle A and 3 marks for angle C. These two angles are each congruent by CPCTC. Okay, and now that means that these two lines are both parallel, and the reason why I can say that, I can now say that CB, is not congruent, is parallel to AD. And why is that? Well, that's because alternate interior angles are congruent, but again, it's going to be the converse. So we have the converse of alternate interior angles. All right, now we're almost finished. We got down to the very end. We've now shown that opposite sides are parallel. So when we look back up at top, we needed to prove using one of these reasons. We have chosen that opposite sides are parallel, so I can say statement 10 that ABCD is a parallelogram. And why is that? Well, the reason being is that opposite sides are parallel. Okay, again, on a scale of 1 to 10, that was about a 50. Okay, not an easy proof, very challenging. All right, next proof is challenging as well, but not quite as long. This is a short proof. So the sum of the interior angles of any quadrilateral is 360 degrees. Okay, that means when we add up all these angles, we're going to get 360. 60 degrees. Let's look at what we're given. We're told that MAET with both pairs of opposite angles each congruent. So they're saying that angle y is congruent equal to angle y. They're saying that angle x is congruent equal to angle x. Okay, well, what they're really saying, this is theorem 6.2. And in theorem 6.2, it said a figure is a parallelogram if opposite angles are congruent. So we already know that this shape is in fact a parallelogram, but we have to prove it. Remember, theorems have to be proved. So just like last theorem, we're going to prove this theorem. We can't use opposite angles are each congruent. We can't use that. So when I scroll back up and look at the other choices I have, I'm going to put a star by consecutive angles, and this is problem B. Okay, and remember that on problem A, we chose to show that lines were both parallel, that the opposite sides were parallel. We're going to show that consecutive angles are supplementary. All right, and this is how we do it. We look inside and we say, okay, the sum of all these angles will equal 360. So x plus y plus x plus y is going to equal 360 degrees. Well, if I add these up, I get 2x plus 2y is going to equal 360. Next, if I divide everything by 2, I would get x plus y equals 180 degrees. Now, I'm going to stop right there because we don't have to do anything else. We have just proven that consecutive angles are supplementary. That's what we just did. If you look at x plus y, you can use any x and y. You can use this x and this y, this x and this y, or this x and this y, or this x and this y. And we're saying that no matter what x and what y you use, it's always going to be supplementary 180 degrees. So we don't have to do a two-column proof. We're finished. X plus y equals 180 degrees. Therefore, MEAT is a parallelogram. All right, next we have a shape that's called cart. So we assume it's a parallelogram, but we can't assume. We're given that it is, we're given that it is a quadrilateral, and we're trying to show or prove that it's a parallelogram. Let's mark up with what's given. One pair of opposite sides are equal and congruent, or are parallel and congruent. This time we will do a two-column proof. And we have everything here. Draw the arrow down. That's given. Statement 2, just like we did before, let's draw in one diagonal. And I can say that draw diagonal AC. And the reason why is that can also be given. Okay, from there, next, we want to say that by reflexive, CR is congruent equal to RC, and that's by the reflexive property. Okay, so let's put 2 marks on that. All right, and then I'm looking to see what we can do next. We have side, side, we have side, side. Oh, there we go, now I see it. We are given in the problem that we have 2 lines that are parallel. So let's highlight these 2 lines. We can do it in red, that's fine. So this line's parallel with this line. Whoops. There we go. And it's cut by this transversal. And so what forms here is that this angle, angle 1, is going to be congruent equal to angle 2. And you guessed it, the reason why is alternate interior angles. Now this is not converse like on problem 1. This is alternate interior angles because we were given in the problem that one side was parallel. Okay, so it's not converse. We know that these 2 angles are each going to be the same. They're each congruent. All right, from there we have, let's continue our proof. Statement reason. And statement 5, hopefully you can see side, angle, side, and side, angle, side. So triangle, let's spell car, triangle car, is congruent equal to That would be going the other way. CAR, that would be 2 to 1. So triangle RCT. And why is that? Well, that's going to be side angle side. All right, and then from there, what we want to say next is that by CPCTC, I can say that TR is congruent equal to CA. So TR is congruent equal to CA, and that's by CPCTC. Since these two triangles were each congruent, these two sides have to be equal to each other. And then continuing our proof for statement 7, now we can say that cart is a parallelogram, and the reason being is that we have now shown we have 1 tick, 1 tick, 2 ticks, 2 ticks. We have shown that opposite sides are congruent. Therefore, the shape is a parallelogram. All right, we're back to our last proof. We are given that the diagonals of a quadrilateral will bisect each other. Now, this is theorem 6.3, okay? And we were told that if we have a shape and diagonals bisect each other, then we know that the shape is a parallelogram. So we can't use this rule to prove it, but we're going to prove why this works, okay? And we're going to have to use the rules that we have. So let's draw two diagonals. First, let's call this cart again. We'll use C-A-R-T. Now, when we draw our second diagonal, it's going to intersect at a point, and we can call that point M, okay? But I'm going to have point M be up here. Just know that it really is this point here, okay? But I don't want to put point M in here because we're going to mark this up. So just know that point M is on the outside looking in. All right, next, let's start our proof. So we want to draw the arrow down. This is given, and we write given. Next, we're told that diagonals of a quadrilateral will bisect each other. So we can show that with markings. We can say that AM is congruent and equal to TM. And so remember that we still have to say that. Even though it's marked, we still then have to say that. And that's going to be because we were told that diagonals bisect each other. All right, and then we can also say that CM is congruent and equal to RM. And that's the same reason that we used here. Now, out of the 4 proofs, this being our 4th proof, I think this is the easiest one out of the ones that we've had. Okay, but it's still challenging, but it's just a little bit easier than what we've been doing. All right, from there, again, if we can show that opposite sides are congruent or opposite sides are parallel, then we can say that this shape is in fact a parallelogram. So that's where we're going. And I see exactly what we should do. We're going to show that these angles are congruent, angle 1 and angle 2. So statement 4, angle 1 is congruent equal to angle 2. Why is that? Well, those are vertical angles. Okay, and by doing that, you see side angle side, side angle side. So I'm going to jump and say that triangle CAM is congruent and equal. And if I go CAM, I would have to go RMT. And that would be by side angle side. And what I can now say, since these two triangles are each congruent, by CPCTC, AC is congruent equal to TR. So AC is congruent equal to TR, and that's going to be by CPCTC. All right, and we're going to keep going. We've showed one pair of sides that are opposite are each congruent. Now we're going to show the other side. Vertical angles, angle 3 and angle 4. So 7, angle 3 is congruent equal to angle 4. And that's going to be by definition of vertical angles. All right, and let's continue this proof. 8, we're going to say that these two triangles are congruent. So triangle AMR is congruent and equal to triangle If I go AMR, I'd have to go TMC. And the reason for that is that this is side angle side again. So now I know that these two sides are also each congruent. And the reason why I can say RA is congruent equal to CT is by CPCTC. Thanks for joining us. See you next time.